And we have the e-bike team from TI up on stage left. All right, let's welcome Ultra Power.
Good afternoon. My name is Peter Engel. I'm joined by Mark Udak, Reed Cow, Tyler Turner. Excluding Tyler, we are all computer engineers. Today I'm going to tell you about the periodic activity monitoring system. This is a device that we implemented on an FPGA. The main purpose of the device is we take in movement data from a screen, in this case a mouse, using PS2 protocol. We process that data, we store it, and then using DTW, dynamic time warping, we make a comparison to pre-embedded templates. These templates would represent some kind of motion that is of particular value to the user. So say in a medical application, for someone who's suffering from Parkinson's and they're having an episode of tremors, followed by sudden total nervous system shutdown, that's a major issue. That's something that maybe the hospital would need to know, or we would alert a close relative. However, looking at this semester in our progress of this project, it actually had some interesting ups and downs. Previously, in the past semester, we were working with Dr. Suchin as well as Dr. Kafari, and very closely with some of Dr. Kafari's graduate students. However, the project in its original form actually kind of was discontinued essentially, and the students we were working with are no longer on that project. After talking with Dr. Suchin, however, we decided we're going to stick with the DTW. We'd spent 4 months at that point learning it. We took the designs that we were offered and were originally planning on implementing, and without the support of the graduate students, we decided we would simplify the design, make our own design, and within the 4 months get as close as we could to essentially the core functionalities of the original project. At this point, as you can see, comparing the non-critical functionalities to what we actually have, we had to sacrifice 3D motion. So we don't actually, it couldn't be a wearable device as it is. However, if you really consider, all we're losing in that case is processing power, processing time. It's just a matter of plugging in with a different sensor. However, we have a functioning data processing block, functioning comparison and functioning memory. As well as that, our output had to be pretty simple and crude, not necessarily hooking up to some kind of LCD. That would be a future goal, as well as if you consider other applications such as, say, there's an athletic application where you might consider an athlete wearing it on their limb of choice, baseball players wearing it on their wrist, and it would, as opposed to just making this simple comparison, we're making long-term comparisons to a set of multiple motions, and you're telling the athlete, yes, you're moving the same way every time. So that might be a way we might want to accomplish. We had to sacrifice that output, the way we might want to improve it. And then finally, the template storage, as I mentioned, is embedded. It's actually just hard-coded in our Verilog. It would be nice if, especially in that athletic application, to be able to essentially tell the system, I want to put in a new template, make the motion, tell the template to the system, I'm not done making this motion. In general, because we had a short amount of time, we decided we were going to split up what we saw as the 2 main blocks. Myself and Sri worked heavily on the PS2 interfacing as well as the data processing and storage, and then Mark and Tyler worked together on the remainder of the project, which included the DTW comparison, memory, and output. So if anyone has any questions.
Why was the FPGA chosen over the processor?
Well, the original idea was this needs to become a form factor wearable device. So if we could have it working in Verilog, we could very quickly take it down to the layout and fabrication form factor. Obviously, that ended up not being the final goal, especially considering we had to sacrifice some of the because I mean this isn't necessarily a new device. They had some novel ideas that we had to sacrifice, but essentially we did turn it into a form factor.
You don't have an image of what the device looks like. What's the form factor? How big is it?
No, there is a. I've seen a video and it could fit on the wrist, but it was still in microprocessor form. I would imagine you could get it within, not necessarily within a watch, but you could definitely, it would look, like your typical wearable device.
Isn't it something that you're building or something that you're adding on?
That was the original goal. I mean, we had to essentially disband that final goal, final form factor. Everything's been done with FPGA.
I'm confused. What is your hardware?
The hardware, everything is done through an FPGA. So, as a mouse as well. I mean, the FPGA had a built-in accelerometer, but we decided to use a mouse instead to give 2-dimensional data and make the processing easier. It's a little simpler. solely FPGA. So it's all programmed